Hello everyone, my name is Sana Al-Agadi and I am a PhD student in Muhammad V University in Rabat. I will be talking about kinetic and isotherm studies on reactive Blue-21 dye adsorption from aqueous solutions by commercial activated carbon. Introduction. The rapid expansion of modern industry has made water contamination a serious problem due to the uncontrolled emission of pollutants from factories. Dyes are one of the largest sources of these pollutants because of their pervasive applications in textile industries. They present an important risk to aquatic life and the environment. On the other hand, most dyes are carcinogenic, toxic, and take a long time to be photobiodegraded by the environment itself. Currently, there are many methods for treating dye wastewater, such as electrocoagulation, electrochemical oxidation, ozonation, adsorption, membrane separation, and photocatalysis. Adsorption represents a successful and promising approach because of its ease of use, its low cost, the absence of secondary pollutants, and the wide availability of adsorbent materials. Activated carbons are largely used as adsorbents in wastewater treatment due to their high surface areas, high adsorption capacities, and the rapid adsorption kinetics. This presentation aims to present the results of reactive Blue-21 dye adsorption onto commercial activated carbon. Materials and methods. The adsorption tests were conducted in the batch mode for each experimental run. In a conical flask of 30 milliliters, a certain amount of commercial activated carbon was added to 25 milliliters of dye solutions of known concentration. The sample containing CAC was shaken to enhance adsorption efficiency. The suspension was filtered and the concentration of reactive Blue-21 in the aqueous solution was determined using a UV visible spectrophotometer. The adsorption amounts of the dye removal efficiency of the sample were calculated using the following formulas. Results and discussion. The effect of adsorbent dosage of the removal efficiency of reactive Blue-21 by CAC was validated by varying the adsorbent dose from 0.5 to 5 grams per liter for the dye concentration of 200 mg per liter at natural pH as shown in Figure 1. From the figure, it can be observed that increasing the adsorbent dose increases the percent removal of reactive Blue-21 from 92.16% up to 99.99%. Therefore, the quantity of diadsorbs increases. Increasing of adsorbent dosage above 2 grams per liter had major effects on the increase in removal efficiency of reactive Blue-21. To study the effect of initial pH on adsorption, experiments were carried out in the pH range between 3 and 11 for reactive Blue-21 removal. It can be seen that by increasing the pH value from 3 to 11, the removal of reactive Blue-21 by CAC is slightly reduced, and the rate of dye removal by adsorption is high and stable under acidic pH conditions and decreases slightly with increasing pH value under alkaline pH conditions. This trend can be explained by the fact that at low pH, dye molecules easily penetrate the pore structure of the cake surface. A lower absorption of the dye at alkaline pH is probably due to the presence of an excess of OH- ions competing with reactive Lu-21 for the hydrogen bond formed with the cake-coordinated water molecules on the interlayer. The nonlinear fitting results of the kinetic model are shown in Figure 3 and Table 1. The correlation coefficient of the pseudo-first-order kinetic equation was higher than that of the pseudo-second-order kinetic equation, and the theoretical absorption capacity of the pseudo-first-order kinetic model was closer to the experimental measured value. We can say that the pseudo-first-order fits best than the pseudo-second-order kinetics. The correlation coefficient of Elovitch model was not high enough to describe the reactive Lu-21 absorption process. Fitted models parameters from nonlinear method are listed in Table 2. A comparison of nonlinear fitted curves from experimental data and three different isotherms is shown in Figure 4. On the basis of coefficient of correlation values, the experimental data were best fitted by the Freundlich and Timken isotherms models than the Langmuir isotherm, indicating absorption into heterogeneous cake surface. In addition, Timken isotherm shows a strong affinity for the absorption capacity of reactive Lu-21 on cake, an indication of the decrease in height of absorption as the dye coverage of the cake surface increases, and the fact that absorption follows the Timken isotherm. Conclusion. The adsorption behavior of reactive blue 21 from aqueous solution into commercially activated carbon demonstrates that adsorption is affected by various conditions such as adsorbent dosage, initial pH, and contact time. The kinetic studies revealed that pseudo-first-order kinetic is best fitted to explain the adsorption process. The adsorption process followed the Freundlich and Timken isotherm models with significant correlation coefficients. We conclude that commercial activated carbon material can be used as highly efficient adsorbent and for the removal of phthalocyanine dye from wastewater, in particular the reactive blue 21 dye. Thank you very much.